Our goal for this video is to first learn what types of slope there are of a linear graph, and then to get a numerical value of the slope. So when you see or hear the word linear relationships, the first thing that should come to mind is the word line, because linear relationships are defined by anything that would create a straight line when graphed. So if we just think about some visuals of straight lines and what those could look like, probably the first thing that comes to your head is a diagonal line. And we could have those going in both directions. But then there are also two other types of lines, such as vertical or horizontal lines. So all of those would be considered linear relationships. The key feature that makes something a straight line is a constant rate at which the graph is either increasing or decreasing by. That constant rate is what we refer to as the slope. So first off, there's 4 different kinds of slope to represent the 4 different types of straight lines that we could have. It's important that when you're reading a graph, you start on the far left and work your way right. So in this graph, when we start to the left and work our way right, it's important to note that this is increasing. As we move right, it's also going up. This has what we call a positive slope, so it's increasing over time. By comparison, this one starts up top, and as it moves to the right, it's dropping. So this is called a negative slope. Anything that is vertical like this, we call a undefined slope. And anything that's vertical is called a zero slope. This is a small plug. You might have heard some students talk about it over the years, but a video called Slope Dude. I highly recommend you watch it. It is very cringy, but terrific. So if we think about those 4 types of slope, they help us kind of identify what type of graph we have and what it looks like in general. But the problem is, once we get into maybe all graphs that are positive. So if we look at these 3 graphs below, they all have a positive slope. So the tricky thing is, how do we distinguish the difference between them? And maybe a word that comes into your head is kind of how steep that line is. Sure, they're all increasing, but at what rate? So for that, we can actually get a numerical value or a number for slope. The higher the slope, the steeper it is. So let's take a look at how to do that. So one thing that will help us get to a number of slope is to first identify what it is or what it means. So again, it goes back to the constant rate that the graph is increasing or decreasing. And that all relates to 2 things on the graph, your x values and your y values. As you move left to right, aka your x value, how far is it moving up or down, your y value? So it really boils down to 2 things, the rise, and if you think about rise, going up and down. So that relates to your change in y values. A nice shortcut for change in is the sign delta. So delta y, you would read that as the change in your y values. Again, how far you're moving up or down. Compared to the run. And if you think about run, kind of going left and right. So that would be your change in x values. Or again, I love the shortcut of delta x. And that would be comparing how far you're moving left and right. So the steepness of your graph is going to come from comparing those 2 values. As you move to the right, are you moving up or down and at what rate? So we're going to keep that in mind to learn how to get the number value of slope. So next we're going to move to, if you're given a graph, actually calculating the value of the slope. And that definition of slope is really going to help you get there. So the thing to remember is that your slope is the change in y over the change in x, or your rise over run. So looking at how far is your graph moving up and down compared to how far is it moving over. And remember, start from the left and work your way to the right. So what you're going to do for that is pick any 2 points on the graph. So if we start with this one on the left, I'm just going to pick any 2 points. So maybe I'll pick these 2 right here. And I'm going to start by looking at that change in y. So as I'm moving, how far am I moving up or down? So if I'm starting at the far left, I am moving down 3 to get to that next point. Since I'm moving down, I'm going to represent that with a negative number. So my change in y here is actually going to be a negative 3. Then my run, or my change in x, is going to go how far over did I move. So to get to that next point, I traveled 1, 2, 3, 4, 5 over for my run. So the slope of this graph would be a -3/5, which shows you moved down 3 and right 5 to get to that next point. It's important to note that it is a negative number, and that's how you know that it's decreasing over time. So it's dropping 3, not going up by 3. By comparison, if we look at this graph on the right, the idea is going to be the same. I want to count how far my change in y is, how far I'm moving up and down, compared to how far I'm moving over. Pick any two. I'm going to show you an example not picking two that are actually next to each other, but kind of skipping one just to show you. So start off the same, my change in y, starting from the leftmost point. So to get to that next point, I went all the way up here. So that'd be 1, 2, 3, 4. Since I'm increasing, I'm going to leave that as a positive number, so 4. My run would be how far over did I go? So moving to the right, that would be 1, 2, 3, 4, 5, 6 over. Now you'll notice that 4 over 6 can be simplified. I can divide both of those by 2, so my slope here would be 2/3. And that's normally going to be the case when you choose 2 points that are not right next to each other. So because I chose some a little further out, I just needed to simplify at the end. So the good news is it doesn't matter which 2 points you pick, just make sure you can simplify. So if we look at these two slopes, again, this is a negative and this is a positive, and you can tell my graphs are drastically different. One of them is decreasing, hence the negative slope, while the other is increasing, hence a positive slope. So let's do 2 more examples before you try this on your own. You'll notice that on these graphs, there's something missing. There are no points labeled. No big deal when that happens. You're just going to find some good points. And what I mean by good points are ones that are nicely on those corners. So if we look at this graph on the left, actually every point nicely hits those coordinates. So I'm just going to kind of draw those in for myself. Then I know to pick any 2, and that slope comes from that change in y, so how much I'm moving up or down compared to my change in x. The other thing to notice about this graph is the scale of the graph. So if we notice this y-axis here, every point is actually worth 2. So when I'm ready to calculate my slope and I'm looking at 2 points, I need to pay attention to that scale when I'm counting my change in y. So from point to point, when I'm only going down 1, I'm actually going down by 2. So my change in y here would be -2 compared to the run, which here the scale is still just 1. So my slope for this would be -2 over 1, or -2. Then if I look on the graph on the right, again, I'm going to start by picking any 2 points. So again, here it doesn't matter, all of them are technically good. If I start with my change in y, I am going down by 1. And then what's weird about this graph is I'm actually not going over at all. So my change in x here is actually going to be 0. Now, maybe you remember a 0 on the bottom is not okay. Anything that's over 0 would be called undefined. So this is an example of that undefined slope that we talked about at the beginning. But you can see that the work to get to that point was still the same. Your slope comes from that change in y over your change in x. So now you're going to practice these on your own. Remember to check if it's increasing or decreasing. Anything going down, you use a negative number for that. Anything going up would be your positive number. Good luck.